Good morning, good afternoon, good evening, and welcome to AI for Good. My name is Bastiaan Kwast of the ITU, the International Telecommunication Union, and it's my privilege to introduce today's webinar, AI in 5G Towards a New Telecommunication Era, featuring Dr. Zhu Yutao, the president of the China Bank of the BICS Institute for Future Networks, Professor Maziar Nekovi, the dean of the Sussex Zhejiang Gongshang AI Institute and managing director of the 6G Lab, and Vishnu Ram, independent IT consultant. ITU is the United Nations Specialized Agency for Information and Communication Technologies, and is also the organizer of AI for Good, together with 38 UN sister agencies, ACM, and co-convened with Switzerland. For today's webinar, we'll be using the Q&A functionality for an engaging discussion, for which we rely on you to participate. So please post your questions in the Q&A functionality, which you can find at the bottom of your screen. Additionally, we have the chat functionality, which you can use to communicate with other participants. Please make sure to send your message to all panelists and attendees. And with that, I think it's now time for me to hand it over to our moderator for today. Hi, Vishnu, how are you?
Thank you, Bastiaan, and we should start. Thank you so much. Good day, everybody. We would have a very exciting session today. In fact, a very interesting topic, AI in 5G. 5G is hot, AI is hot, so we have very interesting talks today. I would like to welcome Dr. Zhu, who is introduced already. Bastiaan talked about. He's a very eminent senior engineer with the main focus on air interface technologies, evaluation and standardization. He's involved in 3G, 4G, 5G onwards, mobile communication systems, smart city, mobile internet of things. He's president of China branch of BRICS, Institute of Future Networks, and he's also the chairman of ITUR WP 5G sub-working group frequency arrangements. Heavily engaged in 5G applications, AI and network security. Thank you so much, Dr. Zhu, for coming today. It's a pleasure to have you here. Could you please give your talk and take it away? Floor is yours.
Thank you. Thank you for your introduction. I'll share the document. And it's my great pleasure for today to have this opportunity to share my views and experience on the 5G and the AI. And actually, I have been with mobile techniques for almost 20 years. We know that in the past 40 years, we have booming development of the mobile ecosystem. But for the 5G, 4G to 5G, and we know that we are facing to connect the human beings to connect the things. So it's a great timing and stage for us, because we know that 5G we talk about here is not only 5G. Actually, 5G stands for the new generation of the ICT techniques, including the 5G and cloud computing, MEC, and the big data, and also the AI. So today we are talking about how the 5G and AI is providing us this opportunity for the society. So we know that every 10 years we are trying to have a new generation of the mobile techniques. So from 2020 to 2030, now all the operators in the world are carrying out the large-scale network construction. So based on that kind of network, the terminal development and terminal equipment and the service are booming now. But we think the next stage may be 3 or 4 years. the terminals requirement will be we will have more and more terminals, and then maybe in the following 4 or 5 years, we'll have the opportunity to provide more services for that. So the whole industry for the 5G application will be depending on what we have in the past 2 years, and also maybe in the following 8 years. So so we have the expectation for that, because for 5G and AI, and we know that 5G will give us the opportunity to get the information from the human beings and the things. That means we'll have big big data. In that case, we have to use the AI and the MEC to analyze these data. So almost all the 5G applications we think will be the combination of the 5G and the AI. And as I mentioned just now, because today we are very lucky because all the techniques, including the 5G, MEC, AI, and the big data are available for us for commercial usage. So today we can think about how to combine these techniques for the industry. Of course, the AI, we are facing the different stage now. It's maybe we also think for the AI is the third stage for the AI development. But the deep learning of these big data will be now for us to for the development of 5G. So we think for the new generation of the AI development, we need to consider the 6 key missions. Maybe the open and the collaborative AI innovation systems. We are trying to establish that kind of system, and also the cultivate an efficient, smart economy, and the safety and safety is very safety and AI or safety maybe the very important for us, because we have big data, but we have to think about how to keep this trusted AI for us. And also some techniques maybe coming from the manufacturers and the universities, but also we need to think about the AI for the military and civilian integration. So we are, as they know, every kind of the techniques we have facing the different stage. So for AI, it's also this, and we are thinking about the new AI techniques, how to use that kind of the models and for the development of the AI. So for 5G and AI will give us the opportunity for to drive the digital economy, especially the basic software and hardware. For us, we are trying to establish the hardware and platform, and also the software platform for the commercial use for the combination of the 5G and AI. So in China, actually, in 2018, and 4 years ago, we are thinking how we could promote the 5G applications. So in China, we kick off the combination. That's the Blooming Cup 5G application combination. So this year is the 4th Blooming Cup combination. We are trying to, based on the support from the government and the industry, we are trying to invite all the industry, the companies, and also maybe some players to join us for the development of the 5G applications. So in the past 4 years, we have more almost more than 20,000 projects we received. So here the picture for the fourth blooming cup and 5G application and combination. We kick off this combination this year in May, and now it's November. We'll have the closing combination for that. And here I can show a video for that for the what we have from the blooming cup. Can you see that?
It's a new type of infrastructure. 5G will be deeply integrated with various fields of economy and society and bring about profound changes in production and lifestyle. In 2018, in order to encourage the integration and innovation of 5G applications, organized by the Ministry of Industry and Information Technology, MIIT, China Academy of Information and Communications Technology, CAICT, and IMT 2020 5G Promotion Group jointly held the first Bloom Cup 5G application competition. The 2021 competition has been successfully held the fourth session and has received wide attention and support from the industry. 6,000 competitors from 30 provinces, municipalities, and autonomous regions submitted over 20,000 projects. The competition has held regional competitions covering all major provinces, cities, and regions of the country, and also held special events including Smart City, Smart Life, Smart Media Technology, AR, VR, Industrial Internet, Smart Park, Smart Healthcare, 5G Assisted Epidemic Prevention and Control, Cloud Applications, Vehicle Networking, Financial Technology, Smart Business, Smart Transport, and Applied Safety, as well as a number of seminars and salons. The competition continues to stimulate the enthusiasm of the whole society for innovation and continuously promotes 5G technology to take the lead in key areas, facilitate 5G product incubation, innovation demonstration, application popularization, and the development and maturity of 5G industrial application in China. As an innovation platform for promoting the application of 5G integration, Bloom Cup competition will work with the industry to build a prosperous ecology of 5G application innovation.
So actually, we analyzed these 20 projects in the 4 years Bloom Cup combination. We note that most of the projects have to consider the AI techniques and for the development of the 5G application. But we know that in some some scenarios may be very important for the 5G AI, for the mining, for safety and efficiency, and also the medical resources, because we have many information here for the medical scenarios, and also the power grid, because we know that for this kind of typical scenarios, and also the scenario in the manufacturers, we found most of the scenario for the 5G and the AI. So AI for us, we consider which could be or would be very important for the future development for the 5G application. So that's why we are now focusing on the combination of the 5G and AI techniques to think about how to promote that kind of the application. So personally, I coming from the BIFNC, that's the BRICS Institute of the Future Networks. We established in 2019, and in the last year in June, it's our first meeting for the kickoff of this Research Institute. For us, our what we are trying to do is to establish some platform for the collaboration and the innovation of the future network technology, and especially for applications. Because personally in China, I'm responsible for the 5G application, so that's why I'm trying to provide that kind of platform in China and also in the world to promote the 5G applications. So we are trying to develop our 5G and the AI platform for the BRIC countries and also for the other countries, and to share our experience and our combination and our capability for the 5G and AI to promote the industry. We also in BFNC, we have the 5G and 12 networks. That's why we are based on this kind of 12 network and the AI platform. We are facing and we are thinking we could be an open platform for the industry to develop the usage of the 5G and AI. So we believe the trusted AI will be very, very important future project on the for us. So that's what we do in the past few years and what we think about the 5G and AI and the future. Thank you. That's my introduction. Thank you very much.
Thank you, Dr. Zhu, for that very exciting talk. There is, in fact, what you told about the open platform for 5G and AI. That's very interesting to all of us. Personally, I have been collaborating with CICT and AIA in China for quite a bit with the colleagues here. That has been very fruitful and enriching, so to speak. There is a quick question: is the competition, I think the Bloom Cup competition, is it open to participants outside China? That's a question. Could you quickly answer that, please, if you can?
Yes, it's open to the global, because especially next year we start thinking we'll invite more and more players and partners to join us. It's open.
Very good, very good. Thank you so much. In fact, ITU also runs AI ML 5G challenge. It would be great to collaborate. We actually run it in collaboration with AIA in China as well as CICT. So it would be great to talk and collaborate with this Bloom Cup competition as well. Thank you, and please stay for the questions at the end and comments. We will come back to you. Let me quickly call upon Dr. Nekovi, who is here. Very exciting talk coming up from him. He's the Dean of Sussex Zhejiang Gongshan AI Institute and Managing Director of 6G Labs. There is a huge list of interest areas and achievements which I cannot go into today if I take a long time to introduce. But I think this is going to be another exciting talk from Dr. Nekovi. Please take us away. Floor is yours.
Thank you very much, Mr. Chairman. I hope you can see me and my slides as well and hear me well.
We are good. We are good.
So first of all, I'm deeply honored and just want to express my gratitude to ITU AI for Good initiative and also ZT Corporation for the invitation to share with you today some of our research, but also thoughts on AI and 5G towards a net zero communication era. Just a little bit about our research institute, 6G Lab, which is newly established at the University of Sussex campus in UK. And here is some of our very recent measurements in millimeter wave and terahertz channel performed at the campus. And this is our AI Institute, which is jointly with Zhejiang Gongshang University in Hangzhou. And the focus of this is transnational education research in AI, telecommunication, and also robotics, training up to 1,200 students, including PhDs, by 2024. And as previous speaker mentioned, these technologies together are going to shape our society. So it's we are bringing them all together under one roof. Now, so when we talk about 5G, new capabilities and uses, obviously 5G is about still enhanced mobile broadband up to 20 gigabit per second peak data rates. And this is enabling exciting applications such as augmented and virtual reality, ultra high definition video streaming, gaming, and so on. But one of the very important characteristics of 5G is the first generation of mobile communication system that is expanding as the critical network for a host of what we call vertical industries and sectors. And this is enabled obviously by the ability for ultra reliable low latency communications, enabling industries such as industry robotic automation, tactile internet, e-health, autonomous vehicles, and so on, but also the cornerstone for massive machine type communications, the next generation of IoT, which is the enabling technology for areas such as smart grids, e-health wearables, connected sensors and cameras, logistic assets, and remote sensing, and all of that. So this is a really important feature of 5G. And therefore, this brings us to new or next frontiers in communications, where with 5G, communication networks become really omnipresent in all industry sectors, and in fact, the entire fabric of our society and the planet. Expectation is that this trend will continue and in fact, super accelerate in the 6G era, which we are expecting to start around 2030. Now, this is obviously fantastic that 5G will leading the digitalization of multiple industry sectors and this entire society. But what is also extremely important and perhaps is less emphasized is that the 5G will be also an enabler, and in fact, an important enabler for achieving the net zero targets. So on one hand, communication sector is actually at the forefront of taking urgent actions to reduce its own emission. So I will mention a very important recent report by GSMA shows that how operators, vendors, and services are really taking that at the heart. But this is not the biggest contribution that we can make. In the 5G era, perhaps the biggest contribution of our sector is to net zero, is to help other industry sectors reduce their own emission through digitalization and smartization, which means the embedding of artificial intelligence into all industries and society. In particular, there is a very recent research by GSMA and Carbon Trust, which indicates that 5G and IoT connectivity together will enable carbon reduction in sectors that are at least 10 times larger than the communication sectors. And within the 5G's first era, this is equivalent to approximately 4% CO2, overall CO2 emission reduction. Now, these are examples from this report showing that, for example, in sectors such as smart transport and cities, smart working, living, and health, very significant 30 to 40% reduction of CO2 emission can be achieved through the connectivity provided by 5G and IoT and smart mobile devices. So this is three. So this is an extremely significant achievement that we all have to be proud of. On the other hand, we also need to look at the CO2 emission of the telecom and mobile industry itself, of course. Now, communication sector as a whole currently accounts for about 0.4% of world CO2 emission. And this is actually relatively low compared to many other industries, but it's still large enough to have to be tackled. And in fact, this is being tackled globally by operators, vendors, and service providers, as I mentioned before too. The good news is that 5G networks, and I was deeply involved in developing 5G standards in current and also my previous roles in industry, especially on the radio access network, are designed to be 90% more energy efficient than previous generations. So this is excellent news. And as we phase out older generation and move more and more to 5G deployment, this obviously energy consumption reduction is going to be more and more significant. On the other hand, because of the great success of 5G, achieving higher data rates and therefore much higher volume of data, and because 5G is also being used by all kind of industry and other sectors, we are also facing perhaps even a super exponential growth of the traffic on the networks. And this obviously will cost energy, will increase energy consumption. So what we will see here, and this is a curve just to illustrate this, is that as we go from 2G to 3G to 4G, we see, due to the traffic increase, an increase in energy consumption and also associated cost. Now, in the era of the 5G, if 5G is deployed in the same way as previous generations to meet the increasing demand, we will see an increase in energy consumption, perhaps despite the fact that 5G itself is more energy efficient. But the answer to this is that we need to move to AI-enabled systems to optimize and manage the deployment and planning and users of 5G networks. Now, as I mentioned to you, this trend is going to continue in 6G. These are examples of 6G's expected application: full holographic communication, digital twins, and what I'm interested in, digital humans, which is replicating the entire human body in digital in real time. Now, these require our terabit per second connectivity and therefore higher volume of data. So we really need to start very early to tackle these challenges. Now, as I mentioned to you, the community, the industry, and academia are already working on that. And these are examples that I've looked and wanted to briefly share with you, such as PowerPoint, which is a 5G energy saving in coordination with 4G with AI by ZTE. There's a very nice white paper that describes these techniques. Automated MIMO energy management with AI, for example, that's by Ericsson and others. In our group, we are looking at radically new ways to redesign the 5G baseband, or 6G baseband rather, with deep neural networks, and also to use artificial intelligence in order to enable a much more energy efficient beam forming and beam tracking in 5G and 6G. So that's on the RAN, but also on the core, there is a lot of fantastic research and commercial deployment happening in order to reduce further energy consumption through the use of AI. For example, AI-assisted and machine learning-assisted observation, prediction, and respond to user traffic to save power, and so on. Energy consumption obviously is the biggest cost component, operational cost component of operators. So besides the desire to contribute to net zero cost reduction is also an important example. So I've just picked up a few examples now from research that we or others are doing. The first one is to look at the 5G's antenna technology challenge. As we all know, beamforming and massive MIMO is an extremely important component of 5G networks, in particular for millimeter wave frequencies where beamforming is required to achieve high data rates, but also long range. Now, the state-of-the-art techniques for beamforming focus on hybrid beamforming or digital beamforming, which is illustrated here. Now, it is very well known that especially digital beamforming is very much energy hungry and energy consuming, but it's important to have that in 5G networks. It's an example of, for example, how this is needed in order to offer fixed wireless access to users in London. Now, if we scale this up to 6G networks, for 5G, we may need up to 1,000 antenna elements to achieve narrow beamforming. If we move then to 6G, we may need about 100,000 antenna elements, and this is really going to cost a lot of energy as well as being complex. Now, there is a new development in the academia and industry called Reconfigurable Intelligent Surfaces. There is a new ETSI group, which has just been established, and we are delighted to be a member of that, where we are looking at alternatives using something called metasurfaces. And metasurfaces, what are they? They are surfaces that are artificially developed on a sub-wavelength level, where we can electronically reconfigure the dielectric responses and therefore manipulate the electromagnetic waves. And this can be used in our example in order to perform beamforming and beam tracking using metasurfaces based on liquid crystal without the need of this very energy consuming approaches, for example, based on hybrid and digital beamforming. And this is going to save quite a bit of energy on the RF front end, we believe, moving towards 6G or also in 5G. The other area is looking at the entire baseband. So this is the complex signal processing unit that is the heart of our digital communication of 3G, 4G, and 5G. These were designed per signal processing block for a number of reasons, and therefore can result in non-optimal performance. And non-optimal performance will then require more energy, for example, in the bit error rate versus signal to noise ratio. Now, we have been looking, and with other research groups also, to replace this entire signal processing blocks with deep neural networks. And that will enable us to have a holistic optimization of the entire baseband processing blocks, which means that we are able also to optimize for energy reduction in a sort of holistic manner. And furthermore, it will also help us to achieve higher performance in difficult or challenging situations. So, for example, this is an example of interference in a very familiar aspect of interference, which is in cellular networks, but also Wi-Fi, where adjacent systems interfere with each other, performing co-channel. Now, we have found that if we implement this deep neural network, we are able to, in very severe interference scenarios, and achieve a much higher performance, as these curves indicate, using autoencoders in terms of energy versus bit error rate than the conventional modulation techniques such as QSPK and BSPK. And obviously, if we can save energy per bit to achieve the same performance per network pairs, we are able to achieve an overall energy reduction, which is going to be quite significant. And this is an example how this actually works in principle. So these are two interfering sender-receiver pairs, and as they interfere, they're able to dynamically reconfigure the constellations, so the digital constellation, in order to really minimize interference. This is obviously not possible with the existing and conventional approaches that are implemented at the moment in our systems. So this brings me to the conclusion of my talk. Well, first of all, I would like to thank you very much for your attention and once again for invitation. And secondly, first of all, what we see is that if 5G is deployed in the same way as previous generations to meet increasing traffic demand, despite the fact that 5G is much more energy efficient, so much more care is put into reducing the energy consumption, there could be a significant increase in consumption of networks. However, as recent work by industry and research has shown, it is possible to roll out 5G and reduce energy consumption by deploying, operating, and managing access, core, and transport networks in a much smarter way by using artificial intelligence. And also to look ahead, we therefore expect, and we are working in this area in 6G Lab very much, that 6G RAN core and edge design need to have net zero as a key objective. And to achieve this, this needs to be guided by artificial intelligence, as I provide you some example of it. So thank you very much for your attention.
Thank you very much, Dr. Nekovi. Excellent talk, and thank you for the references. Yes, I think these are very complementary to what Dr. Zhu just now talked about as well. Very exciting set of studies and research. Thank you for bringing us this very exciting fields. Can I now look at the questions, and can I please ask, invite Dr. Zhu as well? Thank you so much. In fact, both of you, please, if you don't mind, so that I can ask both of you to comment on the questions. Yes, thank you so much. There is a question on the energy efficiency, because 5G requires supply of energy, as Dr. Nekovi just now explained. I think the more my take on this question of trade-off, the trade-off between how much energy is consumed by 5G, whereas how much it can save by using the techniques that Dr. Nekovi just now explained. That trade-off is quite interesting. Actually, the question is about that. The question is, can you explain, maybe give some examples? You already, I think some of your examples were quite good. In fact, your conclusion was also related to what the question is about, the energy efficiency of deployment of 5G networks as against its requirement for supply of energy. Could you, do you have anything more to add, Dr. Nekovi, please?
Yes, first of all, thank you very much for this excellent question. I actually used to work for a telecom operator and know that cooling data centers was a major issue. We designed, for example, algorithms for more efficient cooling in Saudi Arabia, for example, using some initial AR techniques. So what I would say that if you look, the telecom community, we can do our own research in order to improve the operation of our own systems. So this is something we take to our heart. And secondly, we can influence also other sectors, as I mentioned here. simply because we want them to be more energy efficient for our benefits, but also generally. So I would say from a research perspective, I think we definitely need to focus on areas such as signal transmission and computation, which comes to radio and access and core networks in the first space. But we need to have a really serious dialogue, and we have started just a project in UK working with the energy sector in order to see how we can jointly work on, reducing consumption in, for example, smart grids or energy consuming data centers and so on. So I think both are important, but in the terms of research, that will be the main focus for us.
Thank you so much. Can I ask Dr. Ju, would you like to comment? Because you also in your talk talked about applications. You talked about AR, VR. You talked about the different types of verticals and big data. I mean, big time about big data. So what is your take on this whole trade-off about energy and its advantages 5G brings?
Thank you. It's a good question because when we carry out the 5G networks, we know that the energy consumption will be a big and very difficult for the operators because it's the energy consumption maybe it's some limited for us for the development of 5G, but we have to say that maybe the energy efficiency we need to think about the energy consumption we provide the service. I mean, for each bit how energy we consume. That will be the different because for the 4G, 3G, and 5G, because 5G provides more and more and big compatibilities for us. So definitely, maybe the energy consumption will be more compared to the 4G. But maybe we have to think about how to manage the network. And also, I mean, for the AI MEC, maybe it's possible for us to, based on these kind of techniques, to provide more energy efficient and development of the 5G. Thank you.
Thank you very much, both of you. There is a question which asks, what makes 5G mobile technology differing from previous technologies except for speed, bandwidth, latency? Yeah, so the speed, bandwidth, latency are quite clear, but apart from that, what makes it different? I would like to start with Dr. Ju. He did bring out certain very interesting applications. He did talk about edge, AI edge just now. There was a wide area of applications that he talked about in the Bloom Cup challenge. From your experience, what makes it different? What are the, I mean, apart from the application space, apart from the deployment options, what makes it different?
Thank you. I think the big difference for the 5G with the previous techniques may be the connections, because we found that for the 5G we face more and more connections, and based on that kind of application, we have to think about the MEC, we have to think about the AI. That's bringing us the different new techniques for 5G. So for my experience, or my views, maybe the connection will be the key characteristics for 5G. Thank you.
Dr. Nekovi, would you like to add something?
Yes, thank you. I fully agree with Dr. Cho, and I also just want to compliment that. Obviously, those are the sort of KPIs on the, but on the system and architectural level, also 5G has a number of innovations, such as edge, the combination of core and edge, which enables closer to user applications, and that also helps with energy performance actually. but also enabling some of the more exciting applications that need to be closer to end users, and network slicing, which is really the architectural innovation that was introduced by 5G, enabled to allow operators to operate all these fantastic services on different slices, which are isolated from each other, yet using the same physical infrastructure. So these are a few innovations that comes to my mind.
Thank you so much. We stay with you. The next question is the exact definition of net zero. So I think this is a question for you. What would you define exactly as net zero?
Yeah, thanks very much. So, I mean, put simply, net zero basically refers to the balance between the amount of greenhouse gases, so CO2, that is produced and the amount that is removed from the atmosphere. I think this is a very excellent target because obviously technologies emerging now are able also to remove greenhouse gases from the atmosphere. So we need to rely on technology. And therefore we reach net zero when the amount that we add is no more than the amount that is taken away. Now, how to achieve this is a really great challenge, but that's, to me, is the definition of net zero. I hope that's helpful.
Yeah, thank you so much. There is another question on energy, includes energy for signal transmission, computation, etc., which partly do you think deserve more research efforts for applying AI for the green network? I think you mentioned this a little bit. In fact, one of the things which I would like to highlight from your talk is this AI designed aspect. You did mention that ITU in its talks, expert talks, has brought this up many times, that lesser coordination, lesser signaling is possible with this kind of AI designed networks, as you correctly pointed out in your talk. I want to ask your opinion about this overhead reduction, that is including signaling, computation, cooling requirements, especially using AI or applying AI.
Yeah, absolutely. I mean, so that is really the big area. So 5G was designed in an era that AI was just about to emerge as also a big thing. So the design went largely parallel, but now we're seeing that also with 5G advanced, we are getting more AI components in really the sort of a coordination management of 5G networks. And this is, as I indicated, and work by ZTE and others have shown that that can help greatly reduce energy consumption. Now, moving forward to 6G, what we really require is that the artificial intelligence becomes a part of the design already. So not just about the coordination and management, but also the design of the RAN and core need to embed techniques from AI into this. And I gave an example how we replace the baseband processing units, which is very energy consuming, using deep neural networks. And we think that that will help also with energy reduction.
Thank you. Dr. Ju, would you like to add something? You did talk about use of big data and vertical related applications. So I want to ask you if you would like to add something to this.
Yeah, we have the focus on the development for the 5G application, especially for the different industries, and we noted that it's very important for us to use the AI for the network and also for the solutions in different scenarios to save the reduce the energy consumption, and also to maybe AI will be a very important for us because and we have to think about how to deal with this state and the informations to for the more efficiency use of the energy.
Thank you so much. Have you started to explore AI integration with 6G? So shall I start with Dr. Nekovi? He just explained about after 5G and 6G. So Dr. Nekovi, would you like to take this question about exploring AI integration with 6G?
Thank you very much. Yes, as I mentioned, we've been focusing on 3 areas. First is the 5G, 6G radio access network design. So we have been starting to look at that, and I'll give you examples of that using deep neural networks and also encoders. We have been also looking at the core side, so the sort of next generation network function virtualization and cloud natives, where we make use of something called microservices. So microservices enable very good composition and decomposition of services into smaller parts. And if we then use machine learning to collect data, we are able to then do migration of functionalities from core to the edge dynamically. We have been looking at that mainly for latency questions, but I think that also is helpful when we are looking at energy consumption. So these are 2 areas I can mention that we are working on.
Thank you so much. Dr. Ju, what's happening in BRICS for 6G?
Well, actually, we have more interest on the solutions and how to, combine the techniques for the application. So for now, we are trying to find the scenarios for that. So maybe for 6G, it's too early for us, but I think it will be similar for 5G and for the 6G with the AI. So, thank you.
Very good. I think in future we will see Bloom Cup for 6G. Yeah. Okay. There is a question on RIS. Dr. Nekovi talked about RIS. In fact, ITU had detailed talks on RIS. We did host talks on RIS, which went into depths of what are the advantages and technologies. But however, here the question is interference management, mobility challenges in heterogeneous networks. Is it possible to use RIS along with the deep learning solution to mitigate interference and mobility challenges? I guess this also is feeding back to your comments earlier about future networks, 6G beyond 5G networks. Maybe such solutions can be used to an orchestrated RIS-based solution can be used to mitigate interference and mobility challenges. I want to ask Dr. Nekovi first, please, what is your opinion?
Thank you very much for that question. Yes, RIS is obviously a very hot topic, and I'm delighted to hear that ITU had a series on that, and I will definitely try to watch those recordings. I think it was great to see this. As I mentioned, there's also an ETSI group established now at the plenary meeting very recently. Now, IRS is all about being to intelligently manipulate the radio and electromagnetic environment using this sort of metasurface structures. And obviously, what is from telecom engineers is very important is the interference environment. And therefore, yeah, I think that could be a very interesting application. For example, in say a manufacturing plant or somewhere like that, indoor situations. So far, we have been trying to battle this interference using approaches such as beamforming and so on, and managing interference management. But yes, if we are able to manipulate actually that radio environment instead of having to adapt ourselves to that through use of RIS, that could open a host of new opportunities, I think. it's an early stage. So, I will invite you to, if you're researching in that area, to definitely continue it. And I'm also happy to chat with you if you're interested to work with us.
Thank you so much. Dr. Ju, any comments?
Well, we are talking about the wireless technologies. So interference is always the challenge for us, because and so we have taken many years for the development studies for the network, but yes, we have to face that challenge. Maybe it's not easy for us, but I don't think the how. I'm not sure if with the deep learning solution or the AI could solve this, because it's actually the difficulty for the mobile system. Personally, we have to take that kind of research, but it will be very difficult, I think.
Thank you. There is a question on legacy mobile devices. There are still a lot of 2G devices. They are still around, maybe forcing the networks to be backward compatible, maybe perhaps forcing operators to maintain the legacy networks. I can relate to this one. I know that in several parts of the world, 2G devices are still very popular because they are very cheap. Maybe they cost less, and it's sometimes the reliability is a little better with 2G devices. But that's just my perspective. I want to ask, perhaps generalize this question a little bit and ask Dr. Nakovi. Is the backward compatibility an overhead, first of all? Secondly, is this a problem in other aspects in terms of energy consumption and other types of overheads in coexisting 2G devices, please?
Yes, thank you very much. And I'm sure Dr. Zhou has also excellent insight into this area. So from the 2G, 3G, 4G, as we see, as we move to new generations, they actually become more energy efficient. So I think that is interesting. And backward compatibility means obviously operators have to maintain their existing infrastructure in order to serve those users. But on the other hand, the consumption is actually quite low. That's good because this is mainly for voice and SMS. So I think the impact is not going to be very significant when it comes to energy reduction. Because those services, they're very low data rates. So yeah, that's my initial thinking.
Dr. Ju, would you like to comment, please?
Yes, thank you. It's a good question for us because we know that we have 7 billion people, and the operators have to provide service for the different requirements. So we have requirements for 5G, but maybe for some persons, 2G or 3G is enough for them, and also the cost and the fees for the 2G is low, and also in some rural environment, maybe the different the 2G or 3G or 4G is quite different for the provide that kind of service, and also for the operators because we 4G and 2G, 3G, maybe they also for the whole networks they can provide that kind of service and earn the money. So that will be okay. I think the market determine how or if we need that kind of networks or service. So so 2G, 3G, 4G, 5G now we have, but in the main cities we need 5G maybe, but maybe some different environment 2G is enough. That's the determined by the market. It's my opinion. Thank you.
Very interesting perspective. Thank you so much. Thank you, both of you. We are kind of running out of time. So I would like to thank both of you. Very incisive insights, I should say, and very interesting perspectives, very complementary talks. I think on one side, you talked about applications, market-driven forces, and on the other side, you went into details of the architecture and features and deployments and so on. So I think this is an excellent session in my opinion. And the questions, I should thank the audience for the lively set of questions which came up. It helped us to query you both very well and answer all the questions. Thank you for answering all the questions very patiently, digging into your set of expertise. We hope to talk to you very soon. We hope to keep in touch. On behalf of my colleagues, I would like to thank you very much, and on behalf of the audiences as well. I want to call up, there is Bastien. That means I need to stop. Over to you, Bastien.
Thank you, Vishnu, and a big thank you to our speakers, Dr. Nakavi and Dr. Zhu. We hope you enjoyed today's discussion, and we will be launching a quick poll that will be appearing on your screen now. Please let us know how much you liked the webinar, and in the meantime, let me mention a few things that may be of interest to you. So this afternoon, we have a webinar in the Trustworthy AI series. It's called Making Deep Machines Right for the Right Reasons, featuring Christian Kersting of the Technical University of Darmstadt in Germany. We also have a session in our climate series next Wednesday, Better, Machine Learning for Improved Climate Models and Projections, featuring Pierre Gentin of Columbia University and Veronica Ehring of the German Aerospace Center. And next in our AI, ML and 5G series, we have AIoT, where IoT meets AI, the marvelous world of tiny ML, featuring Marco Zenaro, the Ambassalam International Center of Theoretical Physics, and Marcelo Rovai of the Federal University of Itaiuba. Please join us then, and I would like to once again thank our host, Vishnu, our speakers, Dr. Zhu and Dr. Nikovi, you, our participants, our partners, sponsors, and our co-convener Switzerland, and we hope to see you soon.
Thank you.
Thank you very much. Bye.
Selector, rewind selector, rewind selector, rewind selector, rewind selector, rewind selector. Selector, rewind selector, rewind selector, rewind selector, rewind selector.